I always ask them, is anybody at the company using that model you built? 9 times out of 10, the answer is, I don't know. To which I respond, how can you tell me this is a successful project if you don't even know somebody's using it?
Pedro, I'm excited to be able to chat today, hear more about Ople AI. To begin, can you share what do you do? What is the concept of the company in 5 seconds? Very brief.
It's to help companies get a return on investment in AI. And
Everyone, I like it. Pretty simple. Return on investment.
Yeah.
That's important. So tell me, where did it begin? What was the problem that you initially saw? You're like, I need to solve this.
So I've been a data scientist for 19 years, some in academia, some in industry. And I started to see the same pattern of problems, which was even though good scientific work was being done, whether in companies or labs or research institutions, there was still a gap between a model being finished and a real return on investment happening. And that seeing that gap, that discrepancy started building up with frustration in me, and seeing that AI is such a wonderful tool, a wonderful field that wasn't producing real results to the business. So I wanted to do something about that.
You saw the potential of it, but seeing it wasn't really being used, really solving problems being in the marketplace. What was the first iteration then of the product? Like, all right, now I'm going to make use of it. How did that begin, and where are you now today?
Yeah. So there's a lot of steps. And like you said, what was the first iteration? What is it now? And those, obviously changed. I think very few products nail it the very first time around. And so to start, we created a tool that would take the work of the data scientist and help speed it up, right? Because if you think about what the gap in my mind was, it was the model being finished, being handed off to somebody that's not a data scientist, because that's ultimately the person who's going to use it. It's a model to improve somebody in marketing or sales or logistics, and those are the people using it, right? And when that happens, those people wouldn't use the model either because they didn't trust the model, understand the model, or know what to do with the output. And so those things can be solved with more communication between the data science team or data scientists and the final users. The other problem is also problem formulation. Even before you start building a model, data scientists would be building things that nobody else wanted because there wasn't enough communication. So I thought, okay, if I automate the work that the data scientists spend most of their time in, then they'll have more time to do more communicating, right? Because I'm freeing them from the thing that takes all the time. And I was very wrong, because the reason they became data scientists was because they liked doing that thing that was taking all their time.
And communication was not their real interest.
Yeah. And and that's fine. There's nothing wrong with that. And that kind of was highlighted also throughout my career. I've interviewed over 200 data scientists, and one question that I always ask is, tell me about a successful project. And they'll spend 15 minutes telling me about all these techniques and cool algorithms, and it's fascinating and I like it. I'm a technical guy, so we will spend the time chatting about it. When they're finished, I always ask them, is anybody at the company using that model you built? 9 times out of 10, the answer is, I don't know. To which I respond, how can you tell me this is a successful project if you don't even know somebody's using it? You're telling me it was 94% accurate. How many correct predictions did it make this year? Nobody was using it. 0. It was 0% accurate, right? So, that kind of highlights the point that I'm making. And to the trust component, I mean, my first job was in healthcare. Just imagine, fresh out of college kid with no medical background, except for, I did some genomics and stuff, but not really medicine, telling doctors of 30 years how to do their work, right? Because I built a model that says, hey, this patient, this is how this disease is going to progress. And having them trust, right, kid that is barely shaving, you know,
Yeah, it's not gonna happen.
yeah, not going to happen. Because, you know, you all know, right, medical field is known for how humble the doctors are, right? Like they have a history of humbleness to the
Oh, very
core,
much.
very much. Uh, so anyway, so that's where the product started, right? And then I realized, okay, let's shift then and see if we can help the non-data scientists directly,
Mhm.
right? If we create a tool that's even easier to use for non-data scientists where they can build their own models and they can get some value out of it, then maybe we're going to be helping solve the problem, right? And then it kind of evolved into, okay, what are all the things they need to trust, understand, know what to do with the output, right? Those things that I mentioned are the gap. And once we had those in the product and started interacting with the non-data scientists, we also found out something else that was interesting, which was a lot of times they don't even care about the model. The prediction, which is the holy grail of why somebody built a model, sometimes it's almost secondary and they just want to understand more about their data. So much, you know, more than just, you know, some kind of prediction. And so we started what I dubbed, and I didn't write about this yet, so the term doesn't exist, but I'm hoping it'll catch on, which is data explainability, right? Everybody talks about model explainability. What about data explainability? What can the model tell us about the data
Mm.
that's interesting, right? That things that you wouldn't be able to find just because the combinatorial explosion, which is factorial, way worse than exponential, right, makes it impossible. So that's something that we're going after with the product, and we have a lot of things that we just added that are under that realm that we're calling data explainability.
So it's really that you realized communication is the issue. They're not communicating both before they start, they're solving the right problem or trying to build the right model. And then after, have they used it? How are they using it? And where you've realized the gap, it sounds like, is they don't necessarily just want, hey, here's a prediction, go take this and do this. They want to understand facts, interesting knowledge about their data they didn't know before so that they can go and make better educated decisions.
Mhm.
And so you're trying to bridge the gap between the data scientists, analysts looking at the data, and then those who are using it, that they can work better together. Did I
Yeah,
get that
yeah.
correctly?
Hmm.
For you, your business model as sounds like it's evolved. Your target market, is it the data scientists or is it the business users
The
that
business
you're
user.
targeting more? Business users.
Yeah.
But the data scientists are the ones who are on the platform using it as well.
No, the non-data scientists are the business user, data analyst, business analyst, the Tableau user, the
Hmm.
Excel spreadsheet user.
They're the ones using it.
Yeah.
Got it. For a use case, an example, can you share one of more recent ones with any clients that kind of give a good taste of it in action?
Yeah. One is it's really simple example. It's just with sales leads, right? It's an organization. They have a small sales team, I think 25 sales execs, and they try to sell their product. They have a software product as well, and they sold it to about 100 um, customers, and they tried to sell to another 200 that didn't buy it. So they had a small little data set of 300. And then they went to one of those companies that sell sales leads where you buy like here's the email you need to contact and information about the company size and whatever. So they had this massive data set of 30,000 sales leads. And they're like, well, we're not going to go after 30,000 sales lead. And we could go after them randomly or alphabetically or, some other non-intelligent way, or we could build a model that at least gives us slight higher chances of going after the deals that might have a chance to close. And that's how they use our tool. They input the data of the 300 deals that they try to sell with 100 successes, 200 failures. And that's a really small data set, but it's better than nothing, right? That's the question always people ask. Is this data too big? Is this data too small? It's like, if it's all you have, then what good is am I going to, if I tell you it's too small, you're not going to magically have more data. use what you have today. It's better than no model, right? Unless it's like, insanely small. But in this case, I wouldn't call it insanely small. And so that's one use case. The other one, it's a company. They're consultants, but they also have they sell like a analytics package, like put together in Tableau, where they look at your data and they give you insights about it. And this one is for hospitals, when they're billing the insurance companies on procedures they've done to get, you know, um, refunded by the insurance companies. And it's a model that basically tells them things that they might have filed incorrectly, problems with the filing, so that there's so much money that's lost because of back and forth. And the insurance company goes back and says, wait, you forgot this or that, or you didn't file this correctly, and then it's, for one of their customers, they said it's something like 20 to $25 million a month that they lose because they didn't file things properly. So if we can save even a small percentage of that, that's an insane amount of money of just having a model, because they can't go over and double check everything. There's too many filings. They don't have enough people. Yeah.
What is the opposite? If they weren't using your platform, what would they be using, and what gain would they get by using your platform?
Well, nothing. Like, for some of these scenarios, it's literally nothing. There's too many things to go after with too few resources. And even though they're losing that much money, the hit rate would be so small that still wouldn't justify. So they just accept it as a loss. They average it into, well, that's the price of doing business. We lose X many million a month, and that's that.
But for your product, Opal, what would a data scientist or a business analyst be using? Where then, if they came to yours, how is it different?
Yeah, so the data analyst would have to partner with a data science team or data scientist and have the conversations and build the model. And, that would be a several month long engagement, especially even more so if you add the fact that most data science teams are really busy because they're being bombarded from every department in the company saying, build me this, build me this. And they have to choose, right? They have to prioritize. And sometimes you're going to be at the bottom of the list and you might have to wait a long time. I mean, I've seen projects where I've talked to other data scientists and they said, oh yeah, that team's been waiting for this project for 2 years. And here's the honest answer is they're never going to get it. The reason is it's not a fair line that progresses, because if you have like sales team, marketing team, logistics team, and let's say from the CEO down, they're like, look, team A has priority because they're more important to us. Team A is going to produce new projects every few months. So they're never going to run out of projects, which means you're at the bottom of the list. You're never getting to the top. Team A, 3 months, new project. And every project Team A produces is more important than yours. And that's why the data scientist was honest with me and said, that team's never going to get it. Like, I'm never going to have time to do their project. They've been waiting for 2 years. They're going to wait for another 2 and another 2 and another 2. So, the idea, and there's so much AutoML coming out there, and there's so many data scientists afraid that the idea of AutoML is threatening to their job. And that's just very wrong. The way I see it is, currently imagine even a company with 20,000 people, they might have only 10 people that are AI literate, right? The idea is the job of the future for the data scientist is not to be the 1 out of 10,000 that is data literate. It's for them to leverage AI software like AutoML to then be the shepherd that teaches and spreads AI literacy through the company, and is kind of the pillar of help and support, right? So now he's equipping thousands to use this software, and he's still the trusted source to help, to teach, to engage with them, to make sure they're using it correctly. That's a super important job. That's a fantastic job. And there's always going to be some projects that require non-conventional data science. and building algorithms that are bespoke. And
Mm.
those are going to still always fall on them because they require research. They require things that are not just, okay, train a model, tune it, the usual, rigmarole, right? And those exceptional projects are still going to fall in their lap.
Wow, you pose an interesting concept of data scientists, those who are AI literate, going from head down laborers to educators and empowerers,
Yeah.
empowering the entire business to use AI.
I think that's what I call the data scientist 2.0. We're, I think, within a few years away of that transition happening. It's not going to be a friendly transition. It really isn't. I mean, didn't the same thing happen with like DevOps people with the cloud, right? The cloud came, every DevOps person was, scared, right? Saying, "Oh my gosh, my job is at risk," right? Because if my job currently is to make our own cloud, and if the cloud out there is offering what I do, then I'm out of a job. They're not out of a job. There's still tons of DevOps people, but now their job is managing something much bigger. It's an elevated position. But they didn't it wasn't a friendly embrace when the cloud came. DevOps people were saying, "Oh no, we don't need the cloud. I got this. I got our own little cluster here." You know, and eventually the company said, "You know what? But this is way more efficient." And I think the same thing's going to happen. And very few are going to be ahead of the curve and adapt. The majority is then they're going to follow, say, "Well, they're not hiring me for this anymore, but they're hiring me for this new position. So I better change with the times."
I'd love to then push forward a little bit more. What's your most favorite feature that you guys have recently released that you're pretty psyched about?
It's part of the data explainability. It's what we call intelligent subpopulation. Sorry, interesting subpopulations. It's intelligent insights. It's like the header, but then it's interesting subpopulations. So what does that mean, right? So a subpopulation is some kind of intersect of feature values. So for example, let's say you were trying to sell whatever t-shirts online, and you send out these promotional emails to people to try to get them to come and buy, and you're trying to predict which email suits best which person to increase the probability of them buying, right? And then you build a model to predict that, to predict if I send this email to this person, what's the probability they're going to buy our t-shirt. So you have demographic information about the people, maybe level of education, how much money they make, do they own a house, are they married, gender, age, etc., right? And let's say from understanding the data, you know that people over the age of 50 usually have a increased probability of buying your shirts. For some reason, this email works really well with people over the age of 50, right? Let's say, similarly, people in the state of Florida also really well. Of the 50 states, your emails work the best in the state of Florida. It's a clear like 10, 15% higher probability than any other state. But people over the age of 50 and in the state of Florida, the two things combined, you would expect it to be even higher probability of them buying your shirt. They have a negative 30% compared to baseline of buying your shirt. So that's a really weird thing, right? And that's the subpopulation is defined by, again, people in Florida above the age of 50. That's the subpopulation. And it's interesting because it doesn't behave as expected, right? For some reason, you can do well with everybody over the age of 50 and everybody in Florida, except for those two combined. So there's something there that you need to look at. I don't know what it is. You understand your business. You might, and you certainly need to look at that. So we're automatically finding all these interesting pockets, interesting subpopulations, and bringing them to your attention of really unexpected behavior where two feature values really behave erratically. That's the example of it's very hard to, you can't just look at every combination because it's a factorial growth. So very quickly, with even a small amount of features and feature values, you're talking about trillions, quadrillions, quintillions of combinations. And so, you can't just go searching for all of them. And we automatically find them and bring them to your attention. The most interesting ones.
The magic of AutoML, automatically showing it to you. Can you share more about then the underlying technology of your platform, how a little bit more how it works and how it stands out from anything else out there?
So one of the things that we did from the very beginning that was very different, and then it actually kind of opened the box to do all these different things, was if you look at most, probably all AutoML companies, there's usually a pretty straightforward formula, right? Which is data comes in, and there's going to be a little bit of help with the data, meaning if there's missing values, everybody knows how to impute or replace with certain standards. If there's high cardinality features, if there's an imbalance in the data set, standard stuff. So you do something to these values, you kind of prepare the data set. Then there's some feature engineering. What if you try normalizing this feature? What if you try scaling it differently? Standard stuff. After you do all those different things with the data, then you start building models. So you say, well, there's all these different algorithms. Why don't we try them all? Why don't we try boosting and logistic regression and a support vector machine and maybe a neural network? And then you have within each of these selection of algorithms, you have all the parameters. If it's a random forest, is 1,000 trees, 100 trees? How deep are the trees? Depth 3, 7, 38? How do you choose how to stop the growth of the tree? Are you going to do some pruning on the trees? Every algorithm has a bunch of parameters, and you can't just choose all values of all parameters. So you're going to use some kind of intelligent or pre-baked preset values. Now you go from one data set being tried with 10 algorithms, each of these algorithms being tried with 100 different sets of parameter values. So now you're trying 1,000 or 2,000 different algorithms, and then you say, okay, which one did best? And then that's it, and you present that to your user, and you say, I tried these 2,000. This one is the best one. So we wanted to model what we did based on the way people win Kaggle competitions. If your users don't know, Kaggle is an online platform where companies put money down and say, hey, we're GE. We would love it if you solve this problem for us. Here's $100,000. And then, 10,000 data scientists go there and try to win that money and build the best models possible. And I've had a lot of collaborations with the very best Kagglers in the world. I mean, we've hired the #1 Kaggler in the past, won I think over 50 competitions, millions of dollars in prizes, and understanding exactly how they work. And one thing that they all do in common is what's called ensembles, which is, why not, instead of using just the best model, why don't we combine the best 100? It's fascinating. It's a whole conversation why ensembles work. And it started off a couple hundred years ago as the mathematician, his cousin of Darwin, I forget his name. But anyway, he realized that when they had those fairs and people guessed the weight of a cow, you could bring in an expert to guess the weight of a cow, somebody that raised cows and knew cows and had a really good guess. Or you could grab 200 random people and have them guess the weight of the cow. And if you average their guesses, it was usually better than the guess of the expert. It's really interesting, right? To me, it makes visual sense if you think of an expert dart thrower that can always throw a dart within a couple inches of the bullseye. And now you imagine you have 1,000 people, each of them throws 10,000 darts. So you have millions of darts. If they all miss randomly, they completely fill the dartboard, solid. What's the average of that? Bullseye, right? Anyway, so ensembles work. So we said, okay, well, let's do that. Let's do what the best do. Let's ensemble. So we ensemble. The problem with ensembles is that you end up with something that, yes, is good to win a competition, but no, it's bad to put in production. It takes a lot of compute. It's a little more flimsy as far as more things can break because you're running different algorithms, sometimes different libraries, different languages. It's just brittle is the best way to say. So people don't want to put that in production. It's also costly to keep it. So we said, why don't we build this ensemble so that we know what the best model would look like? And then we use the ensemble to teach one final model to behave like it. So normally when you train a model, the model's trained on the data, right? All our models are trained on the data except for the last one. The last model is not trained on the data. It's trained by the other models. And then that final model is all the advantages of a single model, but it has the accuracy almost identical to that of the big ensemble. That was a cool differentiator in the beginning, and it certainly helped us raise money. It was very cool technology. And at first, it just seemed like that was it. That's all it could do for us. But that process of models teaching models, not directly, but kind of opened the door to a lot of the things that we're doing now that allows to do data explainability. It's a kind of branched off of that technology into things that you can't just do if you just have a model. You need to have some kind of different kind of system of teaching in order to create these other insights.
Adding those additional layers that keep it stable, but making it more better accuracy but still very easy to use. I did a quick Google search for our audience. I Googled cousin of Darwin math, and I see Sir Francis Galton.
Francis Dalton, yeah, not Bacon. Francis Bacon, no, not Francis Bacon.
Yeah.
Anyway, that's a completely different person.
But that's an amazing concept of then how that can play a major role. So for you, moving forward, this is 4 years in now?
Almost 4.
Yeah, January 4. What are you most excited about coming up, going forward into 2021 and beyond?
So the whole data explainability thing is really new. We worked a lot of that this year, and we're 1 week away from releasing the subpopulations. So it actually comes out this coming week. And we have 2 more things already after that. One that's about a month out, and then the other one is probably another month after that. So it's starting to see how customers and how people react to that. I mean, we've already presented this to people, but not in the product. We've presented like, here's what the screens are going to look like, here's what it's going to do, and we're trying to get people's reactions. And so far, the reactions are great. But you know, I want to see what it's like when it's actually working in the product and people get their hands on it, and then seeing if it has the value that I see and that the feedback that we're getting. It seems like people really want it. So I'm excited to see how that plays out and opening up a whole new field of what the value is behind building machine learning models.
Who are the ideal companies and size and demographic that can use your platform? Is it a certain size?
No, I mean, we've dealt with companies. Our smallest customer, it's I think 5 people. It's a small startup. It's like, you know, the beginning. I think they're in their first year. They just raised some money through an accelerator. I want to say $400,000. And they're, like I said, I think 5 people. And our biggest company is one of the Fortune 50. So they're big, right? Yeah. So, you know, it's the entire range. Right now, we've noticed, kind of stumbled upon the fact that consultants, like consulting companies and system integrators, have really fallen in love with the product, and we're seeing a lot more success with those companies. A lot of them want to actually embed our software into their software, and so they want to basically offer in their software, right, the ability of not only AutoML, but the whole data explainability and model explainability stuff, and all these values of analytics. And most of the time, it's not even that they want their customers to build their own models. They're building the models to their customers, but they want to expose to their customers all these insights that we're finding. So we're making it easy for them to embed our software into their software.
So it's more like almost like an API or a license ability to end viewability going on their end customer.
Yeah.
Gotcha. Your overall business model is just a monthly, yearly subscription? How does that work?
Yeah, it's a yearly subscription.
Gotcha. And if people want to learn more, where do they go, and what's a good first step for them to take?
Ople.ai, and you can contact us there if you want. I mean, you can sign up right away to start using it for free if you want to play with it without, but if you need help, if you want to talk to us to understand a little more, we're happy to schedule some time and show you the product, give you access, but also give you a little 1 hour lesson and talk to you about what you think you want to build with AI and data science. And we're happy to get on the phone with you and do that.
Have you seen a company using AI, machine learning, or other technology to transform the way we live, work, and do business? Go to uptechreport.com and let us know.